I'm going to demonstrate the derivation of the quadratic formula using the method of completing the square. The quadratic formula is used to calculate solutions to second-degree polynomial equations of the form ax squared plus bx plus c equals 0. Since I'm going to use the method of completing the squares, I want the leading coefficient to be 1, so I'm going to divide both sides of this equation by a. Now, in order to complete the square, I want to add half the coefficient of the first degree term squared. I don't want to change the equation, so I'll also subtract that. Otherwise, the equation's the same. Adding and subtracting what I need to complete the square. Now the first three terms actually are a square. And we're left with two other terms which are just numbers. No variables involved. I'm going to rewrite b over 2a quantity squared as b squared over 4a squared. Now I'm going to move them to the other side. And instead of c over a, I'm going to write 4ac over 4a squared. So I added b squared over 4a squared to both sides, and then I subtracted c over a from both sides. And instead of writing c over a, I actually wrote it as 4ac over 4a squared, so that my terms on the right now have the same denominator. And now we have something squared equals a number. No variables involved over here on the right, so we can attempt to solve this by taking the square root of both sides. I'm going to actually write a version of the equation with the square root sides there. Now, the square root of something squared is the absolute value of that something. So the left-hand side becomes the absolute value of x plus b over 2a. And the right-hand side, I'm going to write it a little bit different. Instead of a square root of a fraction, I'm going to talk about it as the square root of the numerator over the square root of the denominator. Because the denominator is a square, and so I'll be able to simplify that. In fact, why don't I do that right now? I'm going to interpret the absolute value sign by putting in a plus or minus sign on the other side of the equation. And if a is negative, the square root of a squared is absolute value of a. Well, either way, it's absolute value of a, but I need that absolute value sign normally because without it, you might return a negative value for the square root. Now, I'm just going to ignore that absolute value sign in my next line. Why? Because I see that if a is negative, this will basically change the sign of this entire side of the equation. But I have both the positive and negative versions, so I would simply make the positive into the negative, the negative into the positive. So this actually doesn't do anything for us here. in terms of what two values we have over here on the right. So I could ignore that. That's a fine point. Sometimes I've done this derivation and not even mentioned that it was an issue, but in fact, yeah, the square root of 4a squared is 2 absolute value of a, and a certainly could be negative, I guess arguably at half the polynomials. Anyway, I'm going to subtract b over 2a. And I have the quadratic formula. Done. In the form that we normally present it. Notice that if b squared minus 4ac is positive, we get two real solutions. If it's 0, we're left with negative b over 2a, which is one real solution. And if it's negative, we get an imaginary part to each of the two solutions, and so we have complex solutions. And that is my version of the derivation of the quadratic formula using the method of completing the squares.